So, welcome, dear listeners or viewers. This is our third lecture. In this third lecture about machine learning, we will actually go directly to machine learning. In our previous two lectures, our two previous lectures were concerned more with mathematics than with machine learning. This is our first encounter with machine learning. So, our first that I should say machine learning, our first experience with it. What is machine learning? That I'm not going to tell you. You will yourself understand what machine learning is. I will start simply with an example. The example is like this. Suppose we have a number of people like this. These are different people. Okay, and then these people have each person has a weight and a height, two variables associated with each person. One is height, the other is weight. Height and weight. Okay. Suppose a person has a height of say 160 centimeter, and his weight is say let us say it is 70 kg, for example. Instead of 160 centimeter, we can write this height in terms of meters. If we convert this into meters, we have to divide this by 100, because 1 meter contains 100 centimeters. So when you divide this by 100, you will get 1.6 meter. 1.6 means you can yourself check by dividing this by 100. You can get 100 ones are, and then 0.6006 are, and so on. For those who or not do not have mathematical background. Okay, we could have directly calculated measured height in meters. That would be better, and this is what I have done. Height is 1.6 meter and weight is 70 kg. We then find the body mass index of this person. Body mass index of this person. Body mass index of this person. What is body mass index? It is a number, a quantity that enables medical professionals to assess whether a person is obese or not. If a person is obese, then the person is at several health risks. Such a person, an obese person, has a greater chance of cardiac arrest. He has an elevated chance of brain hemorrhage. He has an elevated chance of sugar, this diabetes, and so on. The thyroid. There are so many these problems associated with medical problems associated with obesity. Everyone of us knows. That's why doctors advise us to change our lifestyle of a sedentary lifestyle and be active. Anyhow, that aspect is well taken care of by doctors. Let us take care of this machine learning. When I calculate BMI index of this, and BMI index is calculated by dividing weight by height square. Dividing weight by height square. Now, when I calculate this body mass index for this person, what I have to do, I have to divide weight 70 kg by height square. Height is 1.6 square. It is for this body mass index. It is must that weight should be in meters, kg. Sorry, weight should be in kilograms, and S should be in meters. Now, when I do carry out this division, it is 70 divided by 1.6 square, means 1.6 into 1.6. That we know that is famous, but for those who don't know it, it is here is a calculator. 1.6 into 1.6, and that gives us 2.56. 2.56. Okay, 2.56. Well, So we don't need it now. It is 2.56. Okay. Just a minute. Okay, now 2.56. 70 divided by 2.5. I'm sorry, we still need that calculator. Anyhow, we can get it back. We have it here. 70 divided by 2.56. 70 divided by 2.56. 70. So I have to first erase this. Just a minute. 2.56. That is 70. 70 divided by 2.56. 2.56, that gives 27.34. 27.34. This is the way we determine this body mass index. How do we do it? We divide weight by h square. Why we divide it by weight by h square? By h square, that is a different thing. And for that, one can easily, there are resources available on Google. One can easily check it there. So here I have to tell you one thing. If weight is more, BMI index is more. If height is more, BMI index is less. This means that having more weight is a problem. For a given height, having more weight is a problem. Now, I suppose I collect data, this BMI index or weight and height data of a group of persons. So I collect this for those, that group. I collect W and I collect this weight, height, these two things. Based on the knowledge of these two things, I will find out whether the person is obese or not. How can I find out? First, I will calculate BMI index from these two by BMI. And there is a rule that if BMI of a person is greater than 30, he is classified as obese. If it is less than 30, he is classified as non-obese. 30 is the threshold. This is called threshold. Minimum minimum value of BMI above which people are classified as obese. Okay. Suppose we have a group of 6 persons whose data I have with me. I have worked that out, and in order to save time, I have come with that data here. That is in my files, and here is the data. Here is the data. I will use this data. Now, in this, you can see in under serial number 1, this first person, second person, third, fourth, 5, 6. 6 persons. Of course, when we talk about data, 6 persons. 6% is not enough. The number of persons is not enough to qualify. This data cannot qualify as a sample data. But for us, we can call it. It is basically this data is basically a toy data. So this is a toy example, a simple example that is going to teach us something. This example is in that sense, it is sufficient. But remember that when we talk of data in machine learning, these elements, see how many data items you have. 1, 2, 3, 4, 5, 6. Each data set is called a data point, because we have 6 data points. 6 persons, 6 data points. Now the total, all these data points together are called data set. They constitute data set. So we have this data set. Now we have with this data set we can explain something that's very useful for us, very useful. And let's go for that. What is it? Suppose we have the first data point. So see, we have a graph paper here. Graph paper. On this graph paper, I am going to plot. I'm going to show you these two inputs. Which inputs? Weight and height. weight and height. I will take weight along this axis, height along this axis and weight along this axis. Okay, now this is origin here, right? Now you know we cannot have negative height, so I will not use this because this represents negative height and this represents negative weight. Only this quadrant of the graph. The graph has four quadrants: 1, 2, 3, 4. Only this quadrant will be meaningful for me for this problem. Anyhow, what are the different values of height? Different values of height are 1.65, 1.72, 1.60. I hope this is visible to you. I can enlarge it a little bit. See, let us first take 1.65 is the height. This in meters. Okay, it is in meters. 1.65 in meters. Weight is 70 in kgs. What is this h square? Because we look at it, I have already calculated it. It would have otherwise taken us a lot of time to do this job here in the class itself, in the video itself. So since I need this, I I've already kept it ready there. So height is 1.65, its square is 2.72, and weight of the person whose height is 1.65 is this 70 kg. Similarly, weight of the person whose height is 1.72 is 90 kg. Weight of the person whose height is this is 65 kg, and so on, and so on, and so on. Let me plot these points on this graph. See, when I plot height, what we do, we look which is the minimum height that I have to show. Minimum is this 1.60. No, minimum is this 1.55. We start from the minimum and then see what is the maximum height that I am going to show. Maximum is 1.75. So somewhere 1.55. Suppose you put a cross here. That means you are going to count from this point onwards. Let this point be 1.55. This point is 1.55. Okay, 1.55. Now this 1.55, then there is of course it is 1.55. Okay, and now what is the corresponding this weight? Corresponding weight. Just a minute. The minimum height is 1.55. Maximum height is 1.75. Yes, 1.75. 55 to 75. That means you have see 1.75 subtract. We will subtract 1.55. We are left with 5 minus 5, that's 0. 7 minus 5, that's 2. That means 20. These steps, 20 steps. Now these 20 steps, I will not draw all the 20. What I am going to do, I will I will divide it into steps of 5. One step equal to 5. That means, what does that mean? This 1.55, to this I will add 5. 1.55 plus 5, that is 1.55 plus 0.5, sorry, 0.5. Then I will have 5. 5 5 is a 10. 1, this is 2.05. So no, sorry, we are not going to do this. We will do this thing. 1.55, I will add to it 0.05. 0.05. Then we will reach 5 5 10. 5 plus 1 6. That is 1.60. This 1.55, 1.60, 1.65, then 1.65, 1.70, 1.70, 1.75, 1.75. That is the last. What about these? Similarly, what about weight? The least weight is 65. 65. Least weight is 65. Okay, it is 65. Highest weight is 90. 90 minus 65. 90 minus 65. That gives us 5. 8 minus 6, that is 2. 25. So 25 steps I have to actually show along this graph. The least is 65. I put a cross here. This I will start from this 65 and then I will go for 25 steps. I cannot continue with 5 each because I will not reach here perhaps. This is 65, 70, 75. Oh no, I can do it. 65, this is 70. Let this be 70. Let this be 75. Let this be this 80 and 85, 85, and a little bit higher up you have 90, 90. So these are the weights. Now it is quite easy to show these weights and heights, and we can plot them here in this on this graph paper. 1.55, 1.55 corresponding to 1.55. Here is 1.55. This 1.55. This 1.55 corresponding to this 1.55. The weight is, it is weight. See, this is h square. Don't go there. This is not, we don't need this. 1.55, 74. 1.55, 74. This is 70. This is 75. It is almost near 75. This is the point. This is the point. Okay, then we have another 1.60. 1.60. Here is the this point. You have already this 1. Oh, sorry. You have 1.60 now. 1.60. Yes, 1.60, and you have 65. 1.60 and 65. This is here. The point is here. 1.60 and 65. This is the point. Then there is 1.65. 1.6. Is there any 1.65? Yes. Then for that weight is 70. 1.65 and 70. And then you have 1 point, that is 1.65, 1.70, 1.70. We don't have, but we have 1.72, 1.70 in place. Instead of 1.70, we have 1.72. That will be somewhere here 72, here, and then go up. How much? 1.72, 90. Go up up to 90. Top. This is another point. Still another point is 1.75. 1.75. You have 90 again. 1.75, 90. Okay, 1.75, 90. Good. Then how many points did we get? 1, 2, 3, 4, 5. We have 1 point left. Which is that point? 1.62. This is the point. 1.62, 80. 1.62 somewhere here, and 80, and 80. This is 80. Okay. So what we have? We have a graph here. On the graph, we have plotted height along this axis. We have plotted weight along this axis, and we got these to these 5 data points correspond these 5 points on the graph. 1, 2, 3, 4, 5. 5 points on the graph. 6 points on the graph. Okay, good. Now each point represents a person. This represents one person, this represents the other person, third person, and so on. Each point is like a person, and each person has a body mass index. Let us calculate their body mass index. When I'm not going to calculate that, but I have calculated that, and see look at here. The person with weight 1.65 has a body mass index of 25.7. Person with weight this height 1.65, that's here. This is the person. He has body mass index of 25.7. I will not write here body mass index 25.7. I will write one thing here. What is that? Since the body mass index of this person is less than 30, the person will be classified as, he will be classified among the group, he will be classified as non-obese. Non-obese. Let us classify people with non-obese, people who are non-obese. Let us show them with a cross, non-obese. Cross should have been for obese. Anyhow, it doesn't matter. So we will show non-obese with cross. So I put a cross on here. That means the person is non-obese. So remember this thing. Cross means non-obese. N-O-B, non-obese. And circle or dot will mean obese. Right. Now here is a person who is non-obese. Then second person with weight of with height of 1.72 has a body mass index of 30.5. 1.72. Here is 1.72. He has a body mass index of 30.5. He's obese. So dot obese, obese, because body mass index is greater than 30. Now third person is he has a body mass index of 25. 25. Third person. What is his height? 1.60. 1.60. 20. So this person will be denoted by a cross. Non-obese. Cross means non-obese. Non-obese. Now the next 1.55. 1.55 is 30. That is again obese. 1.55 obese. That means dot and encircled. Okay. Then you have next 1.62, 1.62 and 80. 1.62, 62. Yes, 1.6. This person is 1.62 obese. This person is obese. Okay, good. Obese. Right. Now obese means that we have to show it with dot and circle. Okay, then this person comes the last person. Now last person left is that is a person with height of 1.75. 1.75. He is non-obese. 1.75 is this is non-obese. So cross. Let me redraw this figure here. You can see it clearly. What I want to show you, you can see that clearly. It is weight on this side, height on this side, and we have then points. We have a point here, this point. First, let's take this point. This is we will have again to show some this 55, 65 from 65 onwards. You have 65 here, 65, then 70, as you know, 70, yes, then 75, then 80, then 85, and then 90. Okay, these are the weights. 90. And height 1.55. Here 1.55. Let this be 1.55, and then 1.60, then 1.65, then 1.70, then 1.75, 1.75, then 1.85, etc. 80, sorry, 1.80, and the one point is here, 1.55, and you can see 1.55 and 74. 1.55 and 74, 1.55 and 74 here. And what was his body mass index? He's non-obese. He's obese, sorry. Dot with circle. Obese. So this dot with circle. Then 1.60. 1.60 was 1.60. Where is that? That is here. Non-obese. 1.60. 1.6065 is non-obese. 1.65. 1.65 and it is near 70. That is this cross. 1.65 and here somewhere here non-obese. Then 1.7, 1.65. Then anything else? Yes, let us see what is it. 1.60 we have. Yes, 1.65, that is it. 1.70, 1.70, 1.70, there is no one. 1.72 is obese. 1.72 is obese. 1.72 is obese. It is 1.72. Let me see here. What was 1.72? What 1.72? 1.72, 90 degree, 90 kg, 90 kg. That means this, and this is obese. You can see this is obese, and 1.75, then 1.75, here is 1.75, and 90 is non-obese, okay. Non-obese, you can see 1.75 and 90. His body mass index is 29.4. is non-obese because his height is his height is quite good, and for 1.70, for a height of 1.72, sorry, what was it, is 90, and 30.5 it comes. Okay, then have we, yes, we have actually missed one point. Perhaps that is this point here. This point, this point corresponds to 1.62, 1.62, 1.62, this 1.62, 30.53, 1.62, 1.62, and weight is 80, 1.62, weight 80, and obese case. It's obese case. So look how many data points you have now. 1, 2, 3, 4, 5, 6. Okay, if we can separate this data set into two groups, one group will be data of the obese, that will show obese people, the other group will show non-obese people, then we say that we are able to classify these data points. This is classification problem. Classification problem means when you can categorize these data points, when you can categorize data into groups. The present this example is about binary classification. In binary classification, you classify data into only two groups. Then you could also have data in which you will have to classify data into three groups. Say, for example, the groups, one group could have been dogs, cats, and say dogs, cats, and say goats. Three groups. Similarly, you could have a different number of groups into which you will have to classify data. When you classify data, let's first take binary group is quite simple. Let's take that. Can we separate these data? Can we separate them? Separate. What do I mean by separating them? I mean, can I draw a curve such that curve will have obese points on one side and non-obese points on another side? Of course, why not? Why not? We can. For example, I can go over this curve, say this curve, I can go over this curve. Then the data is then separated by that curve. But can I repeat my answer? Can I separate these data points by using a straight line? Perhaps. Let us try. Let's try. It seems that we can do it. This straight line has these obese people on one side and non-obese people on the other side. This straight line has classified the data into two groups. Okay. Now we can express the same as this. See, height of a person is taken as its input variable, and it is not written as such as by height. It is denoted actually by x. Inputs are denoted by x symbol. This is one input, so it will be denoted by x1, one input, which is height. The other, there is another input, that is weight, because you don't decide about the obesity of a person on the basis of only one input. You must have two inputs. This you must have height and you must have weight. This is weight is instead of weight, we use the symbol x2. Whenever you look at x will stand for input. Inputs in machine learning are also called these features. They are called features. That is more popular than inputs. But we will continue with inputs till the time you get you get familiar with. You are familiar with this new terminology. Now, so whenever you look at x, it means input. Okay, input. Now we have two types of inputs here, x1 and x2, and when I give you these two inputs, you can then decide the output. What is the output? Output is whether the person whose inputs these are, whether he is obese or non-obese. This is called output. If the person is obese, we will denote him. We'll say his output is +1. If the person is non-obese, we will say output is -1. This plus 1 and minus 1, they are just labels. We must not take them literally, in the sense that we might think that these inputs are numbers, for example. No, they are not numbers. Suppose, for example, for a moment, suppose these are numbers. Then if they are numbers, then we can add them. For example, we can add plus 1 and minus 1, we will get 0. This would mean, since plus 1 means obese, minus 1 means non-obese, this means that an obese person and non-obese person can be brought together, and neither both of them will lose obesity. This is nonsense. It is meaningless. So it is not, you are not going to this use them as numbers. For another example that will show you how this ridiculous this statement is, that these are numbers. For example, suppose had this been a number, we could have divided by 2. Now dividing 1 by 2 means divide obese person by 2. Can that reduce his obesity by 2 to half? No. So don't divide them, don't add them, don't subtract them, don't perform mathematical operations on them as such. They are simply labels. You could have written, instead of written plus 1 for obese, you could have written plus 2 for obese, and plus 2 for sorry, plus 1 for these non-obese. Any other labeling could also work. Say, for example, one of the two could be denoted by 0. One of the two could be, we could say this is I could call obese 0 and non-obese 1. But in all these cases, this 1 plus 1, 0, 1, these are simply labels. And now we say that if BMI, body mass index, is greater than 30, greater than or equal to 30, then y is denoted by y. Output is denoted by y. Output is equal to output at that time will be plus 1. Plus 1 means obese. Output will be obese. If body mass index is less than 30, y will at that time be minus 1, that is non-obese. Non-obese. Okay. This problem is called a classification problem. We have classified a set of data into two groups, obese and non-obese. One thing that I must mention, that's very important, otherwise you might have a wrong conception. That is, if this is weight, this is height, weight and height cannot be separated by a straight line. That if a set of data can be separated by a straight line, then we say that the data is linearly separable. Linearly separable. Linearly separable means the data can be separated by a straight line into two groups. In case of weight and height, you cannot do that, because you see you can see this body mass index. See, that is, I'm sorry, I have lost track it. Okay, we will go for another video. After this, we can go for another video, because already the duration of the video has crossed 30 minutes. I don't want to make it too long, but I will return and make another video for this rest of the topic. Okay.